All right. This is properties of polynomials. Some of this is going to be review, and then we're going to build on it. But some of the stuff you're going to recognize from previous lessons. Okay. There's going to be a lot of fill in the blank and filling in charts, and we'll actually go through some of it pretty quick, and then we'll spend a majority or a larger chunk of time on the back and the second page. Okay. So to start out, power function is a function in the form of ax to the n. Okay. A and n are non-zero real numbers. A is your leading coefficient. Okay, we've already kind of talked about A being that leading coefficient. And then n, we've talked about that when we were talking about, x to the n to the m and doing that stuff. So this really, using x as the exponent is not, or using n as the exponent is not really new. Okay. The next part, we're going to talk about words, and these are things that you've probably known since second grade. Mono means what? One. Bi means two. Tri means three. Quad means four. Quint means five. Poly means many. Okay, and this just helps us communicate about the types of polynomial functions we're being presented with. Okay, if it's a monomial, it has one term. If it's a binomial, it has two, and so on. Okay, then, like we just said, a monomial has one term. That term might be just a number all by itself like this. It might be something like this, where it's two things attached together through multiplication. Okay, or it might be something like this, where it's a whole bunch of different things. Those are all monomials because there is no plus or minus something else. Okay, a two-term we call a binomial. A three-term we call a trinomial. But we don't have a fancy name for four terms. We call it a polynomial with four terms. And we basically do the same thing here for five terms. Okay, we have a fancy, nice name for two terms and three terms, binomial and trinomial, but not really for four terms or five terms. So it's just a polynomial with five terms. And we go from there. Moving on. Hey, we're going to be investigating some of these. These are all monomials or polynomials. A monomial is one of them. So a polynomial is when we take multiple monomials and put them together using addition or subtraction. Okay, they are just the terms separated by a plus or minus sign. So the first one, this one would be called a what? Monomial. The second one is a binomial. How about the third one? Trinomial. All right. This is not in your notes. You don't have this on your note sheet, so we're just looking at the screen here. Just some examples here, okay? So this is the monomial, then the binomial, then the tris, then the polys, okay? The monomials, you're going to see they don't have any addition or subtraction. They might have different variables connected through the multiplication, but they don't have an add or a plus sign. Okay, the binomials are two terms separated by a plus or minus, and then so on. Hey, there's one up here. We'll get to that later. Okay, next thing, polynomial function. So that's the next blank you have there. A polynomial function is a function that is in the form of, and then there's a bunch of that like gobbledygook there. It's like just from a different planet. Okay, what that means is that the exponents go in order from least to greatest. Okay, that's what this says right here. So this is the important part of this, is that the exponents, when we are in standard form, the exponents go in descending order of degree. Put some terms up here on the board. So we're going to do, let's say, x squared, and then we're going to do a negative 3x cubed, and then a positive 3x to the fifth, and then a negative 2x, and then a plus 6. Okay, out of those terms, which one should go first? If we're going to put this in standard form, which one goes first? So what we're looking at then is the degree. So we're looking at our exponents, and they need to go in order from biggest to smallest. So which one should go first? The 3x to the fifth, right? So this is going to go first. Then what? Then the cubed, right? Because it's the next biggest one. We don't have a fourth degree up there. Then what? Then the x squared, and I would need to put a plus between because it's positive. And then this one. What's the degree of that negative 2x? Yeah, there's a 1 there. What's the degree of the 6? 0. Okay, if there is no x, the degree is 0. Okay, that's just, we just put that in standard form. All right, now this is the next thing you have. And before you freak out, we're not going to fill in the middle stuff. Okay? For just an example here, I'm going to use smaller. It could be 6x to the fifth. Okay, that would be a quintic example. All right, and then in the middle, we're just going to say like the standard form, the exponents go in descending order. All right, moving on to the next part, talking about solutions. We've already talked about this a little bit. So a polynomial solution is a value of x that makes the function equal to 0. And when we say the function equal to 0, we're saying that the y is 0, which makes it an x-intercept. Okay, so if it's on the x-axis, we call it an x-intercept, which means the y is 0. That's our solution, or our 0, or sometimes people call it a root. Okay, so this is the next part of your notes. It says the on your notes instead of a. But the solution So in this example up here, if you want to sketch this, there are two solutions on this graph, one right here and one right here. Okay, a turn. A graph has a turn if the line changes directions. So if it's going from rising and then starts to fall, or it's falling and then starts to rise. It's going from increasing to decreasing. This is something I would put a highlight next to, an asterisk, a star. The maximum number of turns is 1 less than the degree. So if the degree of the polynomial is 5, then the maximum number of turns is 4. Just subtract 1. If the degree is 6, then the maximum number of turns is 5. You just subtract 1 from the degree. So if you think like the parabolas that we've been graphing and the one that's in the picture, the degree is 2. 2 minus 1 is 1, so we have 1 turn, right? Okay, end behavior. This is at the very bottom of the page. No fill in the blank for this part. But all polynomial functions have properties, and when we look at the different properties, we can decide whether the end behavior is going to be infinitely positive or infinitely negative, and we call that rise or fall. Okay, so here's how we'll always do this. We will always start with the right end. I want you to add that to your notes. Okay, we always start on the right end. Okay, and then if they are even, if the degree is even, the end behavior is the same. So it's rise, rise, or fall, fall. If the degree is odd, they do opposite. So it's fall, rise, or rise, fall. This is going to be one of the greatest resources that you will have for the remainder of this chapter. Okay, it's a very powerful, very helpful little chart. Okay, so we're going to start, like I said, with the right end. So we're going to start in the bottom row. The right end, what we look at for the right end is the leading coefficient. So if we look at this first column, the leading coefficient, they're saying it's positive. If the leading coefficient is positive, then the right end rises. If the leading coefficient is negative, the right end falls. So then we can fill the other ones out too. And that's no matter the degree. If the right end is positive, it rises. Or if the degree is positive, the right end rises. If the degree is negative, the right end falls. Or not the degree, the leading coefficient. Mixing up my words. Okay, now for the left end, we look at the degree. If it's even, it does the same thing as the other end, as the right end. So this one is even degree. So if the right end is rise, that means the left end is rise. On the next one, it says it's even. Our right end was fall, so our left end has to be fall. On the next one, it says it's odd, so it does opposite. Odd makes it go opposite. So if our right end was rise, our left end has to be fall. And then odd, fall, so it has to be rise. We're going to do this one together. So just by looking at this graph, the first thing we want to do is this odd or even? In behavior, both of the ends are doing the same thing, right? They're both rising. So that means it's even. Okay. Then, is it positive? Is the leading coefficient going to be positive or negative? Positive, because it's going up, right? The right end is going up. That indicates a positive leading coefficient. Okay. Now, the number of zeros or solutions. For those, we're going to look right here. How many do we have? 2. So we're going to say there's 2 solutions. Remember, our solutions are just our x-intercepts. Now we look at our turns. I've got 1, 2, 3 turns. Now this one's kind of like, I don't know, backwards. Because we're working backwards kind of, we actually have to add 1 to figure out what our degree could be. So if we have 3 turns, that means this could be the 4th degree. Right? Because what we said is that to go from the degree and figure out the numbers of turns, you subtract 1 from the degree. So to go the other way, we have to add 1. So if we have 3 turns, it could be to the 4th degree. Okay, let's do the next one together. And then I'm going to let you do the others on your own, and we'll talk about them at the end. Okay, so is this going to be odd or even? It's odd because the end behavior is opposite. Okay, is it positive or a negative leading coefficient? It's going to be a negative leading coefficient. Good, because our right end is going down. Now, how many solutions do we have? We have 1. one solution, or 0. Okay, now, is this one, how many turns does it have? 2. 2 turns means it could be what degree? The third degree. Okay, you've got 4 more. I want you to give it a shot. All right, let's do the third one. Odd or even? Just shout it out at me. Even, good. Okay, positive or negative? Negative. Okay, how many solutions? 2. Where's the third one? Solutions are not on the y-axis. Solutions are the x-intercepts, not the y-intercepts. The x-intercepts. So we have 2 solutions. Okay, then how many turns do we have? 3 turns, so this would be what degree? The 4th degree. Okay, next one. Positive or negative? Sorry, I switched up the order here. Odd or even? Odd, because they're going opposite directions. How many solutions? 1, 2, 3 solutions. And then my degree, because I have 2 turns, it could be the 3rd degree. Yep, like that's the maximum number, or the maximum degree it could be. Okay, there are some other things that could happen with like imaginary solutions and stuff that could change this. Okay, all right, next one. This one's kind of weird. So first, odd or even? It's odd. Positive or negative? Positive. Okay, how many solutions? We only have 1 solution on here. Hey, and this one's kind of weird with the turns, okay? But there's kind of a turn here and kind of a turn here. Okay, so we're going to say 3rd degree. All right, next one. Odd or even? Odd, because they're doing different things. Positive or negative? Positive, because the right end is what? Going up. How many solutions? 5 solutions. Okay, then how many turns do we have? 1, 2, 3, 4 turns. So it would be what degree? 5th degree. Okay, other question. All right, now we're going to do the right or the left side together, and then you're going to do the right side on your own. We get out at 25? Okay, so actually, here's what we're going to do. Mm-hmm.